Welcome to all on Sethi Swift Learn. In today's session, I am going to discuss laws of refraction, Snell flow, total internal refraction, lens maker formula under the chapter rays optic and optical instruments plus 2 physics. In this session, I am going to discuss these and this through one question and this through another question. But before solving this question, number of concepts are being cleared, which will be helpful for the conceptual type questions for CUT, NEET purpose and JEE Mains purpose, etc., etc. Therefore, go through the session thoroughly. Now, let's start. Critical angle for a denser medium, rare medium is 45 degree. The speed of light in rare medium is 3 into 10 to the power 8 meter per second. The speed of the light in medium, denser medium is, you have to find, right? This question is taken from JEE Mains 2023, applicable for all these. Concept, applicability and solution. Laws of refraction. The incident ray, the refracted ray and normal to the refracted ray at the point of incidence all lie in the same plane. The ratio of the angle of incidence and angle of refraction. Angle क्या लेंगे? Sin, cos, tan. We have to take here is sin. Sin. Refraction is variable or constant? That is constant. That is constant for the two given media, right? These are the laws of refraction. What is the refractive index? The refractive index is the ratio of speed of light in vacuum to the speed of light in the medium. What is the refractive index? Refractive index is a measure of how much light bends when the travels from one medium to the another medium. If light travels from optically rare medium to optically denser medium, optically rare to denser, then it bends towards. In that case, angle of incidence will be greater than the angle of refraction. If the light travels optically denser medium to optically rare medium, denser to rare, to move away from. In this case, angle I will be less than angle R. Right? Next is the speed in which the speed of the medium in which the speed of light is higher with respect to the medium is said to be optically denser. The medium in which the speed of light is higher with respect to the medium is optical. Optical density is the ratio of speed of light in the ratio of speed of lights into media. This is an important thing. Optically, density should not be confused with mass density, which is mass per unit volume. It is possible that mass density of an optical denser medium may be less than that of an optically rare medium. That is turpentine or water. Mass density of turpentine is less. Mass of turpentine is less than that of water, but its optical density is higher. इसका reverse हो गया. And density is more, mass density is more, than it is not necessary that will be more. Right? Total internal refraction. For a pair of given media in contact can be defined as the angle of incidence in denser medium, for which angle of refraction in rare medium is 90 degree. The value of angle divided in 2 media in contact. When a ray of light traveling from denser medium to rare medium. Denser medium to rare medium is incident at the intersection of two media at an angle greater than the critical angle theta c. For two media, the ray is totally reflected back to the denser medium. Here is the explanation by graph, by diagram. This is the denser medium, this is the rare medium. Ray of light is passing from this denser to move away. Then again, we are going to increase the angle of incidence, angle of refraction is a stage reach where it is theta c, I equal to theta c. When angle of refraction becomes 90 degree. When we increase angle more than this is 90 degrees and this is theta c, angle of refraction, right? If angle of incidence is more than the critical angle, then the ray will not pass through the other medium, it will come to the same medium. That is called total interrefracted ray. This is all about the TIR, right? Now, I will start the question. Question is, critical angle of denser medium ray is theta c is given to you. Theta c is 45 degrees. Theta c is 45 degrees. D mu r. We know 1 mu 2 equal to mu 2 over mu 1 equal to sin I upon sin R equal to V1 over V2 equal to lambda 1 over lambda 2. This is all Snell's law, right? Now, d mu r. D mu r is refractive index of rare with respect to denser. So that will be 1 mu 2 over mu 1. This will be mu r over mu d equal to sin I over sin R. For TIR, at the I should be equal to theta c, that is given to 45 degree, and R should be equal to 90 degree. This comes out to be d mu r. D mu r will be sin I 45 upon sin 90. That is 1 by root 2. According to this, what will be the d mu r? V1 over V2, that is Vd over Vr. That is Vd over Vc. That is equal to 1 by root 2. Then solving velocity of light in density. Velocity of light in denser medium is equal to will be Vc upon root 2, that is 3 into 10 to the power 8 divided by root 2. On simplification, this comes out to be, I think, B option, 2.12. 2.12 into 10 to the power 8 meter per second. B option is correct. And now I have discussed all regarding the what is TIR, what is critical angle, what is Snell's law. Graphically I have represented. All these topics are important for the purpose of NEET, in which conceptual questions are being asked, and this question now can be solved orally after going through this by mind calculation. Right? Now let's start the lens maker's formula. Now, discussion regarding the lens maker formula. concept of lens maker's formula will be cleared by using this question. Question is, biconvex lens of refractive index 1.5 has a focal length of 20 centimeter in air. Its focal length when immersed in a liquid of refractive index 1.6 will be. Four options are given to you. One of the options is correct. Question is taken from JEE Mains 2024. Let's start the question. Lens maker formula is 1 over f equal to 1 over v minus 1 u equal to mu minus 1 upon r. Main thing is very important. This is the biconvex lens like this, right? Mu is refractive index of material of lens with respect to the medium in which it is placed. This is the main thing, only and only this. If this concept is clear, lens maker formula application is clear. What is mu? Mu is the refractive index of material of lens with respect to the medium in which it is placed. Now, first of all, I will 1 over f air equal to a mu g minus 1 over r1 minus 1 over r2. This is equation 1. Now, suppose the lens is dipped in liquid of refractive index medium. This will be m mu g minus 1 over r1 minus 1 over r2. This is equation 2, right? Now, 1 divided by 2. So this will become Fm over F air equal to, this will be cancelled out. Then A mu g minus 1 over M mu g minus 1. Using the formula 1 mu 2 equal to mu 2 upon mu 1. These are the absolute refractive indexes. Absolute means with respect to air, right? Now, further, इसको लिख सकते हैं हम a mu g minus 1 upon a mu g upon a mu m minus 1, right? On further simplification, this will come out to be a mu g minus 1 into a mu g upon a mu m. A mu m divided by the a mu g minus a mu m. This is the formula, right? In this case, there will be three cases. Means mu L क्या? Mu L is the refractive index of the lens, material of the lens. If it is greater than this, if it is less than this, if it is equal to this. If it is equal to this, it behaves as plain glass plate. Focal length will become infinity. Reason? This equal to this. The answer is 0. So 1 by f, that will come to 0. Next, mu L greater than this, nature will not change. Reason? This factor is greater than this. This will be always positive. This is always positive. So nature will not change. F will increase, power will decrease. If this is the case, nature will change. Reason? This may be greater than this may be less than this may be right? This may be greater, it is greater. Greater intensity क्या किस level तक greater है उसके ऊपर depend करेगा, right? Now, nature will change and focal length may increase, may become equal or may less. It all depends on calculation. All depends on calculation. Right? Now let's start the question. Now formula is given is Fm equal to F fair A mu G minus 1 upon A mu G minus A mu M mu M. Simply substituting the values. F fair is given to 20 centimeter. F fair 20 centimeter and F medium is 1.6, 1.5 and 1.6. A mu G 1.5 and A mu M 1.6. A mu M is 1.6. Right? Then substituting the values. FM is focal length in medium. F where 20 1.5 minus 1 upon 1.5 minus 1.6 into 1.6. On simplification 20.5 upon 0.1 negative sign into 1.6. Right? On simplification this comes out to be minus 160 centimeter. Right? So this is, in this case, the lens was dipped in a medium whose refractive index was greater than the material of lens. So nature was changed and focal length increases. All the three cases are possible. Right? Now its correct answer will be minus 160. B option is the correct. B option is correct. Right? If you know this formula, you can give the answer of this question orally. Nature will change, nature will not change, focal length will increase, power will increase or decrease, it will behave as a plain glass. All the questions are covered in this formula. Right? Now I will like to request, if you are new to my YouTube channel Sethi Swift Learn and like this video, please subscribe and share the channel and press bell icon to receive updates on upcoming concept clearing. Be careful. Concept clearing videos. Thank you. धन्यवाद. बहुत बहुत धन्यवाद जी. बहुत बहुत धन्यवाद.